Hello everyone, my name is Tejashree Divakar Dasi. I am from Sri Siddheshwar Women's College of Engineering, Solapur. I am pursuing BTech from Computer Science Engineering currently in first year. So I am here to explain one of the concepts of basic electrical and electronics engineering, working principle of DC motor. In this lecture, we will see first introduction, then construction of DC motor and working principle of DC motor. Let us see first what is a DC motor. A motor is an electrical machine that converts electrical energy into mechanical energy. A DC motor follows Fleming's left hand rule. That is, when a current carrying conductor is placed in a magnetic field, it experiences a force that causes rotation. As you can see in figure, the thumb indicates the direction of force, the index finger indicates the external magnetic field, and middle finger indicates the direction of current. Now we will move forward and see the construction of a DC motor. As you can see in the figure that a DC motor consists of yoke, main pole, armature core, armature winding, commutator, brushes, shaft, magnetic path, terminal box and field windings. Now let us understand the function of each part. First, yoke. It is the outer cover of the motor made up of cast iron or steel. Yoke provides mechanical support and acts as a magnetic field. Second part is the main pole. It is mounted on the yoke. They carry field windings and provides the magnetic field required for motor action. Next is the armature core. The armature of a DC motor is a rotating part that rotates on its axis. It is a cylindrical part of magnetic laminations that are insulated from one another. The armature is perpendicular to the axis of the cylinder and is separated from the field coil by an air gap. Armature winding. It is a non-moving part on which winding is wound to produce a magnetic field. Armature winding is a electromagnet that has a cylindrical cavity between its poles. Next is the commutator. It is a cylindrical structure that is made of copper segments stacked together but insulated from each other. The primary function of the commutator is to supply electrical current to the armature winding. It helps in producing a steady rotating torque. Brushes. The brushes of a DC motor are made with graphite and carbon structure. These brushes conduct electric current from the external circuit and provide it to the rotating commutator. Next is the shaft. Steel rod connected to the armature. It transmits the mechanical power to load. Magnetic path. It is a closed path for magnetic flux which includes field poles, air gaps, armature core and yoke. This path ensures proper interaction between the magnetic field and armature winding. Next is the terminal box. Terminal box is used for external electrical connections to the motor. It provides a secure point for connecting power supply. Field windings. These are copper wires wound on the poles. When current flows through them, they produce the magnetic field required for the motor action. Let us see the working principle of a DC motor. Whenever a current carrying conductor is placed in a magnetic field, a force acts on it. The direction of force is given by Fleming's left hand rule. In a motor, the main flux is produced by the field winding when a DC supply is given to the motor. At the same time, armature conductors also carries the current. The main flux is downwards from the north pole to the south pole, as shown in figure. The armature current direction in the upper conductors is coming out of the paper, while in the bottom conductors it is going inside the paper. So using Fleming's left hand rule, the direction of force on the upper conductor is found towards right and on the bottom conductor it is found towards left. These two equal and opposite forces produces a torque and thus motor starts rotating in clockwise direction. Here only one conductor is shown at the top and at the bottom. In practice, it is found that all the top conductors under North Pole experiences force towards right, and all bottom conductors under the South Pole experiences force on left. Hence, armature starts rotating. The magnitude of the force is given by F is equal to force, that is F is equal to B into I into L, which is measured in Newton, where B is the flux density measured in Weber per meter square, I is the current in the conductors measured in ampere, and L is the length of conductors measured in meter. I hope you understand this concept very well. Thank you.